Well, welcome back. Last time we talked about the kind of documentation that you need to include whenever you write your own functions. We're not at the point where we want to write functions yet, but more talking about documentation as a whole. And so function documentation is an important part of that. Now we want to we're back in this idea that projects are analogous to writing an essay in an English composition class. So an essay is going to be composed of paragraphs. A code project is composed of scripts. So you already are familiar with the RStudio IDE, but right here, your source pane or your editor pane, this is where you would put scripts that you want to save as part of your project. And the console is where the code actually gets executed, the code is run, but this is the source for it. This is the stuff that gets saved. And then here's a bit of the output, okay? We, now, thankfully, we've already kind of broken into the idea of writing scripts and writing Quarto documents. But many people who have used R before, a lot of times they're just like, okay, let me type the commands into the console and see what happens. So we want to offer a little bit more organization and a little bit more structure to our work. So you already know how to do this. New R script, the file, new file R script, or Control Shift N or Command Shift N on Windows and Mac. And take a minute and do this exercise. This should be a review for you because you should have already done this in some previous lessons. Okay, so you should be done with that exercise. As I said, it should be old hat to you now that we've been in this for a while, running code from a script. But here are the rules for writing script. Now, a bit of it I've already talked about, particularly here, point number 3. We've already seen code sections, but this is really, really important here to just kind of go from top to bottom on the rules for writing a good code paragraph, i.e. the rules for writing a good script. So just like in English, there's rules on how to write a good paragraph. In code, there's rules for how to write a good script. So the first part is the code and the script should all be related to one particular component of your analysis. I have seen many times where somebody has this giant gargantuan script, hundreds or thousands of lines long, where they import the data, then they clean the data and they wrangle the data, then they do some feature engineering, then they do some data exploration, and then they remember like, oh shoot, I need to go back and do a little bit of feature engineering before my data expert. I need a little bit do a little bit of data exploration before my feature engineering because I just found out that there's NAs in the data, and then we make some graphs, and then we get into joining on another data set, and you've got all of these chunks, like just so many sections of this giant computer code, this giant script. And then somewhere we were like, okay, and this is where we did regular regression. And then later on, we decided, well, we don't like the output of regular regression, so we're going to do a random forest. And then we have to build some plots after that to visualize the results. And this thing ends up being some giant, huge Frankenstein script that's 5,000 lines long. That's a nightmare. Please don't do that. Instead, write one script where you just explore the data. Find out what's going on in the data. Make sure you include tons of comments like, okay, this is where I got the data. This is who sent it to me. This is when they sent it to me. This is why they sent it to me. Let's go through and start exploring this data. Figure out what's in the data. And that gives you plenty of space to write lots of very detailed comments. You're almost like a field botanist, if you will. You discovered a whole bunch of new flowers and you're writing sketches and you're writing notes, all of this stuff. You're just exploring a new world. And this new world is some new data set. All right. That's one script. Just explore the data set and write down your findings. And then you've got another script, totally different script, where you say, okay, based on what I found in my data exploration, I know I'm going to need to do some data cleaning. So you've got a script just to preliminary data cleaning. Maybe it's preliminary and secondary data cleaning because you come back and say, oh, you know what? I realized later on there was still some more data cleaning to be done. So I'm going to add some more to this script, and this is just my data cleaning script. But it could start off as just preliminary data cleaning, and then you come back to it a few days later and add more. So you've got your data cleaning script. And then you've got a script that's just dedicated to preparing the data for modeling and feature engineering and or maybe like some some stuff like that. So you've explored the data, you figured out what's in it, you've fixed a whole bunch of problems, all the problems that you could find so far, and you've left space for you to find and fix other problems. And now you're saying, okay, let's get the data ready for modeling. Okay. And then you've got another script. And if it is literally just a simple ordinarily squares, you can say, okay, well, this part of the script is where I did ordinarily squares, and this part of the script is where I did random forests. That's fine. If you've got a much more complicated statistical methodology or a couple of methodologies that you're employing, you might think about one script per method and say, okay, well, this is where I'm doing deep neural networks, and then this one is where I'm doing adaptive dynamic quadratic discriminant analysis, and then this one is where I'm doing boosted trees. And so you can have a different script for each of the different methods that you're applying if they are considerably more complex and they need that. And then finally, you should have a script that where you build out tables and figures, maybe a script just for tables and a script just for figures. Who knows? Depends on how big your manuscript is. But all of these things, they should be components, they should be modularized, and they should be saved, preferably with dates. Okay, and we'll get to dates. We'll get to dates shortly. Scripts should be named and right here, we're getting to dates right here, apparently. Scripts should be named and dated based on the part of the workflow that they handle. So I usually use 2 digits right here. So if you only use 1 digit, then that means that you're expecting there to be fewer than 9 scripts total. If you use 2 digits, that means you're expecting there to be fewer than 99 scripts. Oftentimes, even if the project starts off pretty simple, I'll end up at like 12 or 13 or 14 scripts. And then I'm like, oh, shoot, I should have gone with 2 decimal places. Why didn't I? So just from the very beginning, like give yourself the benefit of the doubt that you might get to the 10th script, depending on how complex the data set is, and just start with 2 decimal places. I don't usually need 3. I have not encountered a problem so big that I made it to 100 different scripts of data cleaning, preparation, modeling, and reporting. Maybe that project is waiting for me, but I feel like at that point I would be part of a team, and we'd have an entirely different workflow anyway. So on dates, we can see an example here that this part of the analysis I worked, it was like a couple of weeks out of a month. So I don't have a date I don't have a specific day attached to it, but I do say that it was 2019 and then June of 2019. But notice here that I have the year first, then the month, and if I need to include a day, then I have a day. If you use dates in any other format, that means your computer will be sorting based on maybe everything in June all comes together. Or worse, everything that was written on the 3rd of any month all gets lumped together. So the stuff that you wrote on March 3rd of 2012 gets stacked right next to the stuff that you wrote on December 3rd of 2023. That doesn't make any sense at all. Okay, why would you want all of the things that happened on the 3rd of the month to be grouped together? No, you want to go in order of the logical grouping. So years come first. The things that you were working on in 2018 is probably very different than the project that you were working on back in 2009. All right, then the months. Once you have years, you say, okay, well, the things that I was working on in March of 2018 are probably different than the things I was working on in September of 2018. So you have 4-digit year, then 2-digit month, and then after that you add days, a 2-digit day as appropriate. All right, we already talked about partitioning and chunking using code chunks. Again, it's going to be 6 pound signs and then the title of the section and then at least 6 more pound signs. I go all the way out to 80 characters wide, and that's point number 5, just so that I have some like boundaries for myself. I say, okay, well, I go pound signs all the way out to 80 characters so that I can visually see that everything's fitting within the space. Add comments that help clarify why you are doing what you are doing. Do not write a comment that says, I'm adding the numbers 2 and 5 together. Oh my goodness, we can see that from the code because you wrote 2 plus 5. We've got like 6-year-olds that can read that and say, oh, they're adding the number 2 and 5 together. That's great. Thanks for being so helpful. No, that's not a helpful code comment. What you should be writing is, what is the number 2? Why is it important? What is the number 5? Why is it important? And then why is it important that these 2 numbers be added together? Okay. So why are you doing what you're doing? That's what goes in a code comment, not what you are doing, what you're doing, what you are doing. The only time that I have code comments that explain what code is doing is if it's very obscure code from a package that I rarely use. Then I will say, oh, this function is from this package and it does this. That way, when I'm reading along, I'm like, what does the zoom function do? Why is my computer spinning up a zoom window, a zoom call? That doesn't make any sense. Oh, the zoom function is from some package and it's dealing with time series data and you zoom through a time series window. Okay, that's kind of a helpful comment to say what you're doing. So, but really the only time I'm including comments that say what I am doing is if the function is kind of bizarre or it's one that I don't expect a whole lot of people to know about. It's like some out of some really obscure package or obscure library that people probably never heard of, then I include the comment that says, this is what I'm doing. Um, all right, so then we get to point number 5. Lines in your script should be fewer than 80 characters wide. Okay, does this affect how the computer actually does what it's doing? Again, no. This is purely human formatting. Really, the reason that we do it, there's I spend some time, go down the rabbit hole and click on these links and learn why we use 80 characters wide. My goodness, I think there was something to do with like back in the 1800s, people were taking the census and they used holes. They had like they had this regular piece of paper, and based on where holes were punched in the paper, it would record different pieces of information. And that paper ended up being about 80 symbols wide. And I think it was to do with like some, my God, was it like treasury bonds or something? The government had like a whole stack of these papers that they couldn't get rid of, so that they ended up using them for the census, and they ended up being this particular shape, and that shape ended up being basically 80 symbols wide. And then since the 1800s, that's just what was used then to build punch cards for the very first computers, and then from there it just snowballed and infected all of computing. We could have picked 120. We could have picked 73. We picked 80, I think, because it was something to do with a surplus of paper that the federal government had back in the 1800s that they used for census information. Anyway, it's a long rabbit hole. If you like history, if you're a bit of a history geek, maybe go down that rabbit hole and find some stuff out. If not, just understand that the reason we still use 80 characters wide is because it's the rules, and that's why we do it. And because it's the rules, I will take off points on your assignments if you go over 80 characters. Not because I actually care, but because other people who are going to be hiring you do care. And also, there are certain code repositories that will flag your code if it's longer than 80 characters wide and say, hey, you need to fix this. So anyway, other things, use 2 spaces instead of tabs for indentation. And this is actually pretty nefarious. Your computer in like your eyes interpret white space differently than your computer does. So the computer actually interprets the 2 white spaces for a tab, not as a white space next to a white space, but actually, depending on the language, like for instance in R, it's actually slash T. So slash lowercase t. Now it displays to you as 2 white spaces next to each other. So you, the human, don't see a difference, but the computer absolutely sees a difference. And this will cause problems. 100% will cause problems. And they will be very hard problems to fix because you can't even see where the tab was versus where the space was. So use the space bar on your keyboard. This is unfortunately very annoying for Macs right now because one of the more recent Mac updates, whenever you type 2 spaces on a Mac keyboard, it automatically inserts a period. Oh my God. Why I have not been able to figure out how to turn that off. Eventually, I will figure out how to turn that off, or mark my words, I will dig up Steve Jobs and beat him with a hammer. He's dead, by the way. Okay. Since this is being recorded, That was a joke. I'm not actually threatening to desecrate the grave of a famous person, but it is very frustrating that when I type two spaces on my keyboard, it adds a period and a white space after that. Anyway, some other things, all operators need to have spaces around them. This goes back to something that we covered a few lessons ago. Just put spaces in your code. This does not affect how the computer interprets the code at all, but it absolutely affects how humans read code. So please make the code easy for humans to read. And then some minutia. Other languages like Python will use the equal sign for assignment. We do not. We use the assignment operator. It's read in English as the verb gets. So X gets two. So X assignment operator two is read as X gets two. So use the assignment operator. There's a keyboard shortcut for it. It's going to be Option minus sign on Mac or Alt minus sign on Windows. This is actually in ancient code. Oftentimes you would need to end lines with semicolons. Technically, this works in R, but going back to one of the things that we talked up above, basically everything that you do in R calls a function. This semicolon is actually a function. It's like a carriage return that says evaluate the next part of the line on its own. And so if there's nothing after it, there's no reason to use a semicolon. Honestly, you should not be including semicolons in your code regardless. It's valid computer code in R, just please don't do it. And then this is a point of, I think this is a point of personal preference, but it will actually come to help you out when you get to the strings lesson to be consistent and use double quotes instead of single quotes. And for me, this is just so that if you write some code that deals with character strings that you need to escape or you need to actually find the literal double quote symbol, you can still use a single quote to mark the double quote symbol as a quote itself. That sounds kind of confusing. We will get into it when we talk about regular expressions and string manipulation in R. Okay, this video has been pretty long. I'll hold the example off for that. Actually, I'm gonna show you this example right now because we're gonna end with an exercise, and then I will show you the results for this exercise. Okay, this is some code that I wrote. God, back in was this second year PhD? This was a long time ago. And it is atrocious. So my assignment to you, now that this video is done, I want you to fix this code. Add spaces where spaces need to be. Fix assignment operators, add nice comments, make things fit inside of 80 characters, make this just easier to read overall. Fix names, because names are kind of atrocious. So anyway, go wild. Try to work on this code right here. Okay, see if you can fix it. Okay, and we will pick back up with a much better formatted version of this code in the next video. See you soon.